The next problem we're going to look at is employee scheduling problem. It's like a human resource problem, and this is for a post office, and we have a minimum number of required employees for different days of the week given. Okay, this has been developed. These are our daily requirements. We have to have this many employees in these days. And we also have a constraint that employees will have to be scheduled for 5 consecutive working days and then 2 consecutive days off. So you can have the days off split. It has to be together. So a person is scheduled to begin their work week on Monday. They'll go from Monday through Friday. Now those who are scheduled to begin their work week on Tuesday, they'll go from Tuesday to Saturday, and they'll be off Sunday and Monday, and so on. Now the question here is, how many employees should we schedule to begin their week in each of the 7 days of the week, such that these requirements, the minimum number of employees required, is met, and at the same time the total number of employees we need is minimum. We don't want to have more than what we need, more employees than what we need. And at the same time, we want to meet these minimum requirements. So that is the problem. So let's look at the Excel file. So here we are given employees required. So we have that as a row. So this is a given information. So let's color code it as an input value. Yeah. And the decision variables here are how many workers will start their work week on Monday, how many will start on Tuesday, and so on. So this is our decision variable. So this is your worker schedule. So let's name. So here there is, since there is no label, we have to use define name, and say we'll call it worker schedule. Okay. Now we want to minimize that total employees. So if you sum our schedule, so that will give us how many total employees we'll have to have, and that's what we have to minimize. That's the objective that we need to minimize. So let's give a name again here. Here there is a label, so we can do create, and we'll color code this as the objective function. Okay. Now the constraint. So how many employees will be available in each weekday? So we have set it up in this fashion, and first we have to set up this table that will count how many workers we will have each weekday. So here, if we take the first one, people who start on Monday, okay, so I'm going to absolute reference that like that. Okay, now that's the number of workers who will work on Monday, and they will also work on Tuesday and Wednesday, Thursday and Friday, but they will be off Saturday and Sunday. Okay, now Tuesday, okay, let's do the same thing. Okay, Tuesday people will begin on Tuesday, make that absolute reference, and then they will go up to Saturday, and Sunday and Monday they are off. Wednesday people, okay, again absolute reference that. Now they will go from Wednesday to Sunday, Monday, Tuesday they are off. And then people who start on Thursday, okay, they will go from Thursday to Sunday, and they will also work on Monday. Tuesday, Wednesday they will be off. So Friday, they will work Friday, Saturday, Sunday, and Monday and Tuesday. Then people who start on Saturday, okay, they'll work on Sunday, then Monday through Wednesday. The people who work on Sunday or start their work week on Sunday, absolute reference that, and then they will also work from Monday through Thursday, and Friday, Saturday they're off. Now the employees available each day will be, if you sum each column, that will give us how many workers will be available on each of the work days. So this has to be greater than or equal to. Don't put equal to, because if you put equal to, it may be impossible for us to hire workers in such a way that it will be exactly 17, exactly 13, exactly 15 in each of those weekdays. What we want is to minimize the total number of employees such that we meet these requirements. Okay, so let's give a name for these two ranges. Control, click and drag will highlight discontinuous ranges. Okay, so here is the objective function. This is your changing cells, and those are the constraints. So let's go ahead and go to solver, and we want that to be minimized. Changing cells is that. Now add constraint is that greater than or equal to that. Click OK. Change that to simplex, non-negative, and solve. Okay, so now we have a solution. Let's make sure that these are integers, because they look like the formatting may deceive us. So increase the decimal places and you see that they are not integers. So we cannot have non-integer number of workers to start that weekday and Monday, Tuesday, and so on. So you have to go back into solver and add the integer constraint, so, okay, which is easy. So you got to go like that and change this to integer and solve. Okay, now we have the integer solution. When you do integer, you have to, one more thing that you have to consider is you go into solver and options. Okay, now you need to make sure that this ignore integer constraint is unchecked, because if this is checked, it will simply ignore the integer constraint. And there is one more thing you have to check, is the integer optimality percentage. Now when you require integer answers, the amount of computation needed becomes enormous. Okay, of course our problem is a small problem, so you don't even notice it. But if you have a large problem, thousands of variables and thousands of constraints, this can be a real problem. So often people use 5% optimality or 2% optimality or 1% optimality. So that means Excel will figure out what is the minimum possible objective function value, and then once you reach 1% or 2% or 5% of that value, okay, when you get as close to the integer optimality percentage, then it will stop. So this way you're not going to go for that final minimization or a final small amount of maximization and spend enormous amount of computer time. So instead of that, you get close enough and then you stop. Okay. If you do want the absolute best answer and you're not willing to compromise and you're willing to spend enormous amount of computer time, you have the patience to wait in case of large problems. Of course, our problems is going to be pretty simple. Okay, you put 0, then you're guaranteed optimum solution. Okay, the minimum most in the case of cost problem and maximum most in the case of cost profit problem.